This is the video for Unit 1, Lesson 5, Inverse Relations. The goals we're going to find in this video are to find the inverse of a function using a table, to find and verify an inverse of a function algebraically, and to determine the domain and range of an inverse function. An inverse function is a function that reverses the operations of a function. So typically when we have an inverse, if we have a function we're calling f of x equals y, the inverse of that is going to basically reverse that process. So the inverse, we raise it to the -1, but we basically say the inverse of f of x. So that's when I reverse the process or interchange the x's and the y's. So the first topic we're going to look at is when we have tables or graphs. So if we have a table for our function, so you can see here we have -8, 4, -4, 3, 0, 2, 4, 1, 8, 0. If we do the inverse of this function, we're just going to simply reverse the x and the f of x. So for example, this would now be 4, -8, 3, -4, 2, 0, 1, 4, and 0, 8. So if we're going to go ahead and do the inverse, we're just going to simply switch the x and the f of x, and this would become our inverse. So our output now becomes our input, and our input becomes our output. For a graph, the domain and range for the inverse also gets flipped. So if we look at this graph, this is our original function. I'm going to call this f of x. The domain for our original function, that's basically looking at our x values. So where do our x values start and stop? So you can see this point here, the furthest to the left is the point -1, 3. The point furthest to the right is the point 5, -6. And so when we're doing our domain, the domain is our x values. So we're going from -1 to +5. For our original function, if we're going to go ahead and do the range, our range is going to go from our lowest value, which is for our y. So our lowest value is -6. Our highest value is +3. So for our original function, our range would be from -6 to 3. So if the question is asking what the domain and range is for our inverse, all we really have to do is flip these around. So if the range for our original function is -6, 3, that now becomes the domain for our inverse. If the domain of our original function is -1, 5, that now becomes the range for our inverse. And so when the question asks what's the evaluate the inverse of for f of -3, all we're basically doing is that's the same as saying when does f of x equal -3, right? So it's like we're just flipping it around. This is now saying this is essentially like our y value. So when does y equal -3? So when we go ahead and look at our graph, I'm going to go to -3 on our y-axis. That's actually right here. And I can see that y is -3 at an x value of 2. So our answer would be 2. And that would be our final answer. For the U-tries, again, that's your assignment. You want to make sure that you complete that. We'll check that in the following class. And then the next topic we're going to see on here is verifying an inverse and writing an inverse, right? So if we want to find an inverse algebraically, all we really have to do is, again, if it's an inverse, that means that when I evaluate, I'm left with simply just x. So if I want to find the inverse, all we're going to do is just simply wherever, I'm going to rewrite this as y equals, so 3x minus 10. And to find it algebraically, all we do is interchange the x and the y. So I'm going to interchange. So now I have x equals 3y minus 10. And then we're going to go ahead now and solve for y. Right, so I just kind of switch those around. Now I'm going to go ahead and solve. So if I go ahead and solve this out, we're going to add 10 to both sides. X plus 10 is equal to 3y. I'm going to divide each term by 3. So I get y is equal to x over 3 plus 10 thirds. So that's going to end up being now my inverse. So my inverse, I'm going to rewrite it over here because you might be writing smaller than me. The inverse is x over 3 plus 10 thirds, or 1/3 x. Same thing. So this would be our inverse. So that's one part that the question was asking for. Sometimes it also asks you to verify. So verify means that's a different step. That's if I actually make a composite and see what I get as my final answer. So if I was to evaluate f the inverse and substitute it in. Okay, so you can do it, check that it works for both of them. I'm just going to check it maybe for one of them, but you could do both if you want. So if you evaluate the inverse in the function, it should just come out to be x. So I'm going to go ahead and substitute that in. So I see my outer one is actually f that I'm doing for this example. So we said that was 3x minus 10. So I'm going to write 3, leave a space for x, minus 10. And then wherever I see x, I'm going to go ahead and substitute this inverse expression. So we're going to go ahead now and get x over 3 plus 10 thirds. And we're going to go ahead and simplify it out. So 3x over 3 plus 3 times 10 over 3 minus 10. These cancel out. So x plus 10 minus 10. And then we just get that to be x. So what does that mean? That we basically verified that it worked. I could also do it with the reverse and it would still check out. So for the sake of this, I'm not going to do it a second time with the other direction. But if it is an inverse, it will check out to also be x. In this next example, we're going to end up finding the inverse and evaluating. One thing we're going to find later is that when we talk about something that's invertible, we're going to find that we want to restrict the domain because when we do the inverse, we don't want to get multiple solutions. So, and we'll kind of address that briefly in this example, but then you'll see it pop up in a later video as well. So we're first going to rewrite this with y, and then we're going to switch the x and the y. So now we're going to go ahead and take the square root of both sides. And technically when we do the square root, there should be a plus or minus in there. We're going to find when we do our functions, though, we're going to want them to be invertible. We don't want multiple solutions because that's going to mean that this is not going to match the one-to-one test. So for now, I'm just going to put a positive, but we're going to talk about in the next video how to rewrite this to restrict the domain. Just for now, I'm not going to write the plus or minus, but we're going to come back to that. So for now, I'm just going to write it as the square root of x equals y plus 1. We're going to subtract. So this would be my inverse. And then I want to evaluate f of inverse of negative 9. So I'm going to put a negative 9 or positive 9 in here. So the square root of 9 minus 1. And we're going to get an answer to be positive 2. So my answer would just be positive 2. All right. If you have any questions, you can ask them during T-Bolt time, during class, or come to the center.